think of it really as a big giant screw, right? If you use or a big giant bolt or a big giant screw, you drive that into any surface, you're not pulling it out and you're not driving it in unless you're twisting it, right? So in this application, once it's fixed to the building and all solid, it's not going anywhere uplift or obviously pressure into the earth. So these are our helical piers, okay? And these ones that you see that actually have the helices on them, this is a triple helix. So this is the upgraded version. We tried with the double helix and that did not satisfy the required load, so we went to the triple helix. These leads have varying sizes that have varying capacities. A 5-foot is a small one, a 7-foot is this one. We connect this to the mini excavator with the particular drive head on it, drive it into the ground. It actually is pretty fast. Then when it gets to, a working height, we disconnect the machine, we connect an extension, which is this right here, connect an extension to that, continue to drill it down. We add typically at least one more piece to get to our required depth, while the ground guy is using his iPad to check the torques, and he's just working back and forth with the guy. Get to your pressure, register the torque, make sure that everything checks out, put it in our spreadsheet, move to the next one, 278 times. So when we added a fourth, we started with 2, okay? And sometimes that met capacity and then it didn't. Then we went to a third piece. They didn't really custom make it, but sort of most of the things they do is designed, for various different levels, right? So a triple helix is a pretty extensive. The typical is a double helix, and most companies only carry double helix. So we had to actually change companies at the beginning to go to somebody that had a better piece. And then in some cases, Dave, we did add a specialty just additional helix.
We would add a 14-inch helix, or we would switch to a 14, 12, 10 helix.
Right. So sometimes on top of this, if we weren't going to get our capacity, we would pull this back out and add a specialty piece, which was custom made for us, that one, which was a even wider helix, okay? So this is 8, 10, 12. And then we would add an additional one, which is 14, custom made for us in the wetlands areas where we couldn't actually get the capacities. Then we drive it back in with all of our extensions and get the pressure. Or we had a 10, 12, 14 helix also that we needed for some of the highest capacity areas, and that's again the diameter of these pieces.
That really kicked ass.
And those were significantly better, right? So the size of these plates is really the key. How much surface area are you getting out of these plates in combination is what's actually giving that capacity.